If moderate or severe turbulence is forecast, then this is clearly displayed on the SIG weather chart by the following symbols. Light turbulence is not explicitly forecast on the SIG weather chart. Turbulence can be experienced either in cloud or in clear air. The latter form is called clear air turbulence or CAT. And earlier we saw how this was clearly highlighted on the charts by way of the enclosed dash lines and the CAT legend. In cloud, moderate or severe turbulence is automatically implied on SIG weather charts whenever a CB is forecast. In addition, on the medium-level SIG weather charts, areas of moderate and severe turbulence associated with other types of medium-level cloud are always highlighted by turbulent symbols. These are included within the cloud boxes assigned to every scalloped cloud area. Moderate or severe icing is also automatically implied whenever CBAs are forecast on the charts. In addition, on the medium-level SIG weather charts, moderate and severe icing is sometimes explicitly added to scalloped cloud areas when these contain cloud types with an associated icing risk. Widespread sandstorms or dust storms are highlighted on SIG weather charts only when the phenomena are forecast to significantly obscure visibility between the flight levels at which the chart is valid. The symbol which is used on the SIG weather chart is identical for both phenomena and is shown here. As we learned earlier, the only clouds displayed on high-level charts are embedded cumulonimbus. However, on medium-level charts, you'll find a lot more detailed cloud information. Any cloud types likely to have a significant impact on your flight are clearly highlighted for you. We define this impact as the presence of moderate to severe icing or turbulence. If either of these phenomena are forecast, the specific flight levels where they are expected will be clearly displayed right there in the cloud text box. Looking at our example here, the cloud text box points to two scalloped cloud areas, indicating that broken amounts of cumulus and altocumulus are forecast within those regions. Between flight levels 250 and 100, covering the lower range of the chart, moderate turbulence is expected. And between flight levels 250 and 150, you should prepare for moderate icing. In regions of the world where we see significant convergence of nearly diametrically opposed winds, it is quite common to see significant cloud development. These regions are explicitly highlighted on WAFC significant weather charts because they are frequently associated with hazardous weather and abrupt shifts in wind direction. The position indicated on the chart represents the forecast location of the convergence area at the surface level. The Intertropical Convergence Zone, or ITCZ, is always featured on significant weather charts. Covering the Sub-Saharan Africa region, you can easily identify the ITCZ by looking for two parallel lines marked with the letters ITCZ. Occasionally, the structure of the troposphere is such that we see several abrupt. Let's look at changes in temperature, because in a sense, there are actually several tropopauses. The tropopause heights included on the high-level WAF's significant weather charts are the ones that are most significant for us in aviation. The heights displayed on these charts relate specifically to the lowest temperatures in the troposphere. These tropopause heights are indicated at various spot locations across each of the high-level charts. Tropopause heights are presented in flight levels, and when there is only one tropopause, this flight level is centered in a rectangular box. When several tropopauses exist in the atmosphere, an H or an L is added to the box to indicate whether the upper or lower tropopause height is being displayed. In these cases, the rectangular box is expanded to include that additional symbol, making the box look more like an arrowhead pointing up or down. Jet streams are easily identifiable on WAF's significant weather charts by solid black lines that feature wind feathers indicating wind speeds at specific points, as well as the flight level where the maximum speed is attained. The arrowhead at the end of each jet stream clearly shows the direction of the flow. In our example, we have a jet stream that curves in a northeasterly direction, then gradually veers southeasterly. This jet stream reaches a peak speed of 100 knots at flight level 390. Any changes in speed along the jet stream of 20 knots are indicated by either an additional set of wind feathers or, if space on the chart is limited, to parallel lines drawn perpendicular to the flow of the jet. It's very common for Cat to be associated with jet streams due to the significant amount of vertical and horizontal shear that occurs through the atmosphere near a jet stream. Now, if an erupting volcano is producing enough ash to cause a significant hazard to aviation, then the location of this volcano is clearly highlighted on the SIG weather chart by this symbol. Some additional text is attached to the symbol and includes the name of the erupting volcano and its coordinates. In our example, we are using Mount Etna. Whenever a volcano symbol is displayed on the WF's chart and it's in the vicinity of your area of operations, then it's important to always check for any signals which may be in force. These signals will provide up-to-date flight information regarding the nature of the ash cloud. In this lesson, we have looked in depth at the different elements of the WF's SIG weather charts. It's important that you understand them and appreciate that they represent the best fixed time forecaster phenomena which are of interest to aviation. They should become an important